Hi, future doctors. Welcome to the next class. So we discussed in previous class capacitors connected in series. We will do one or two problems on that, how they are going to ask the problems. Here, two capacitors they connected. So 3 microfarad, 6 microfarad, and it is connected to 10 volts battery. Then, what is the charge on each capacitor? Otherwise, what is the potential difference across each capacitor they are going to have? Either charge or potential difference. Now, these two capacitors when connected in series, what will be same? Charge is going to be same. First, you can calculate what is the effective capacitance. What is the effective capacitance formula? CS equal to C1 C2 by C1 plus C2. So 3 into 6 by 3 into 6 by 3 plus 6. That is going to be 3 into 6 by 9. So it will be cancelled. So this is going to be 2 times, sorry, 3 times. It is going to be 2 times. Therefore, 2 microfarad. Correct? Now, effective capacitance is 2 microfarad. This is 2 microfarad. This is 10 volts. Now, what is the charge is going to be available? Means Q is equal to CSV. So 2 into 10 into 10 power minus. That is nothing but 20 microcoulomb. Now, what is the voltage across each capacitor? What is the voltage across each capacitor means we came to know voltage across 3. V is equal to Q by C1 or C3 means capacitance of this capacitor. What is charge we got? 20 microcoulomb by capacitance is 3 microcoulomb. So 20 by 3. Correct? Yes, this one. Voltage across 6 microfarad. Q by C2. So 20 by 10. Sorry. Charge is 20. 20 by what is C2? C2 is going to be 6. So this is going to be 10 times 10 by 8. Correct? So like this, we can, if you add 20 by 3, 10 by 3, we are going to get 10 volts. You can cross check. Once you calculate this one will be 10 minus this one, you are going to get remaining voltage. Like this, you have to calculate. Otherwise, direct formula we can use. But generally, if you calculate charge and if you calculate like this, it will become easy for you. Okay, this is about capacitors connected in series. Now, what is the energy stored in 3 microfarad? They will ask. What is the energy stored in 3 microfarad means? We gave energy formula. What is the energy formula? 3 formulas we gave. Any formula you can use. Of C1, V1 of what is C1? C1 is going to be 3 into 10 power minus. What is V1? V1 means voltage across 3 microfarad. V2 means voltage across 6. Therefore, 20 by 3. So 20 by 3 whole square. Just if we calculate this, we are going to get the energy. Okay. Now we'll see capacitors connected in parallel. So whenever they have connected capacitors in parallel, when we can say capacitors in parallel means all first plate means this is 1, 2, 1, 2, 1, 2. All first plates connected to one point, all second ends connected to another point. So this combination we are calling it as parallel combination. Effective capacitance. They are going to write CP. CP is going to be C. Now, if you are taking charge, charge is going to be divided in this Q1, Q2, Q3. If we are taking A and B, here charge is going to be Q charge is going to be entering through C. Here it is going to be divided. into three different charges, three different capacitors, C1, C2, C3. What will be same in this means? The amount of work done to bring charge from A to B is same. The amount of work done to bring charge from A to B is same. Therefore, what is same? Voltage is going to be same. V1, V2, V3 is going to be equal to B. V1, V2, V3 should be equal to B. Now, from this diagram, we can write Q is equal to Q1 plus Q2 plus Q3. So, what is Q we came to know according to Yours law? Q is equal to CV. Q is equal to CPV for this CPV. Like this for Q1. What is Q1 here? Q1 is equal to C1 V1. Q2 is equal to C2 V2. Q3 is equal to C3 V2. Substitute here. C1 V1 plus C2 V2 plus C3 V3. What is same here? Voltage is same. Here, voltage is same. Therefore, CPV is equal to C1 V plus C2 V plus C3. So if we cancel V, Cp equal to C1 plus C2 plus C3. So we can know these equations. But why we discuss entire derivation means what will be same and what will be different whenever it is going to be connected in parallel. Now what is the ratio of charge? Q1 is to Q2 is to Q3. In series what we got this? 1 is to 1 is to 1. Now you can see what you will get here. C1 V1, C2 V2, C3 V2. Therefore, C1 is to C2 is to C3. Now what is the voltage ratio? V1 is to V2 is to V3 is equal to voltage is same. 1 is to 1 is to 1. Correct. Now if you are n different capacitors connected in parallel, n different capacitors connected in parallel, what will be the answer? Cp is equal to C1 plus C2 plus C3 plus and so on. N. If n identical capacitors or same capacitors connected in parallel, Cp equal to C plus C plus C and so on C. How many C's? NC. Correct? Now, what is the charge on each capacitance if capacitors are different? So, you can use this. What will be same in this? V1 equal to V2, V1 equal to V. Now, you can write V1 equal to V. Now, what is V1 from this diagram or from this equation? V1 is going to be Q1 by C here, Q1 by C1, right here, Q1 by C1. Next, what is V from this? Here, see here, V is equal to Q by Cp, effective V, Q by Cp. Then what is Q1 means? C1 by Cp into Q. So, if you write Q1 is equal to C1 by C1 plus C2 plus C3 into Q. So, what is the charge? Like that, Q2 is equal to what you will get with our common sense, we can write C2 plus C1 plus C2 plus C3 into Q. Q3 is equal C3 by C1 plus C2 plus C3 into Q. So when we wrote potential, that one term won't come. But whenever we are writing charge, the C1 term will become. Like this you can remember. Next, another important point, very, very important point. Cp is greater than C maximum. What does it mean? In series we discussed Cs is less than C minimum. Correct? Cs is less than C minimum. Now Cp is greater than C maximum. If you connect two capacitors or three capacitors, 1, 2, 3 microfarads, effective capacitance is 6 microfarads. So now the 6 is greater than maximum among the three capacitors. If you connect three capacitors, 10, 15, 25 microfarad. If these three connected in parallel means effective will be greater than which one? 25, which is maximum amount. Now, if those are connected in series, it is less than 10 microfarad. Understood? That is the meaning of this point. Next, what is Cp by Cs? What is Cs by Cp if an identical capacitor is connected in parallel series they will have? So Cp, if an identical capacitor is connected, Nc. For Cs, it is going to be C by N. Therefore, you will get Ns squared is to 1, Cp by Cs. If it is Cs by Cp, reverse. 1 is to Ns squared. So these points are going to be important for this parallel combination. Now, if you connect simple problem like this series combination, same 3 microfarad, 6 microfarad connected in parallel to 12 volts, let us say. Now, what is the charge on this? Charge on 3, charge on 6. Charge on 3 is equal to, what is our formula? CV. C value 3. So both are connected in parallel. Parallel means what will be same? Voltage is same. Therefore, directly we can write, so 3 into 10 power minus 6 into 12 watts. Correct? So 36 microfarad. Now what is the charge on 6 microfarad? They will ask. At the time, Q on 6 is equal to 6 into 10 power minus 6 into 12. Isn't it? So 12 sixes. 2, 7. Correct? Now what is the total charge on this? What is the total charge means? You can find either effective capacitance, Cp into V, otherwise you can add these two, 72 plus 36. 72 plus 36 microcoulomb. Correct. So like this, we can calculate. Now, what is the voltage across 3, voltage across 6 means? 12 volts. By using these, we will do some problems. So this is effective combination of series and parallel combinations. So next class, we will discuss some combinations and problems, how they may are on this. Okay. Thank you.